Hello dear students, welcome back to Pen and Paper Chemistry. Let's continue with our learning of the topic Chemical Kinetics, and this is video number 11. We were talking about the factors affecting the rate of a chemical reaction, and we've already spoken about concentration and pressure, temperature, and we are going to talk about catalyst today. So like I am acting as a catalyst for your learning of this topic. What am I doing? So let's suppose you are at this level. This is your initial when you start off with, and you have to achieve a level here. So this will be your final state. And in the entire process, there's a big mountain of numericals and theory that you have to understand in order to reach the final state, right? This is what the actual situation is. Now, while watching these videos and understanding from these videos, you shall be doing the same. Your starting point and your learning will still be the same. Only thing is, I will help you to make it easier, right? Exactly, that is what a catalyst does. It reduces the peak of this mountain. You see the difference? So, like I explained to you in the earlier videos, this is the energy coordinate of the graph, and your x-axis is the reaction coordinate. Right now, each of the reactants, they are associated with a certain amount of energy represented as ER. The final products are also associated with a certain amount of energy known as EP. EP and ER, they can be above or below each other. Further on, I will explain what I mean by this. Now, when ER has to go to EP, there's a big peak that it has to climb and then go down. This peak is the state of the formation of the activated complex. That means the extra energy that the reactant molecules acquire in order to get excited and be ready to form the products. Just like when we started with video 1, 2, 3, your curve started rising up. You started understanding the topic, and till the time you reached the last video, you were so happy at your learning when you did the numericals on Arrhenius equation. You were super activated. So you were in a state of activated complex. But in reaching that stage, I had to take you through 10 videos before you reached that state, right? In other words, you needed some extra energy, some boosting of energy in order to reach that stage. This energy that is required by the reactant molecules or by you is what we call as the activation energy, right? And now that you have understood this topic, you know that, oh yes, it's easy now. It's not such a big deal. So you are a bit relaxed, right? Energy levels are a bit lower than they were till video number 10, correct? Am I making it too confusing? No worries. Here I have the graph for you. You see, observe it. We've got the potential energy on the y-axis, the reaction coordinate on the x-axis. By the way, are you keeping your pen and notebook with you so that you can note down whatever we are writing over here? These are your notes which you can use for offline reference, and also when you don't have mobile during the examination preparation, right? So what happens over here? This is the energy of the reactant. The reactant molecules, they acquire extra energy known as the activation energy in order to form the activated complex, right? Now, the molecule cannot stay activated forever. You cannot remain in examination mode forever, right? You have to relax as well. So the energy falls down, and this is we are representing it by a curve over here. EA is the activation energy required by the reactants in the absence of a catalyst. Now, what did I do? I didn't learn for you. I didn't write for you. I simply acted as a catalyst. I helped you to lower this tension. You still became activated. You still got the learning, but through an easier route, right? So we have represented the activation energy with the catalyst by the symbol EA dash. Now if you notice over here, your EA dash is lower than the activation energy required for the reaction, correct? So it is, you had to use less energy in order to understand the reaction. Now notice the difference in the two graphs. In this graph, your EP is lower than ER, whereas in the previous graph that I had drawn, EP was higher than ER. So do you think you can explain the concept of exothermic and endothermic reactions with regard to this? Exo means which will give out heat, right? So which of the two graphs is representing an exothermic reaction? Think about it. Here EP is greater than ER. In other words, the reaction mixture, the reactants, the reactants and the products differ in energy in such a way that your products are having more energy. So overall, has the reaction absorbed energy or given out energy? So identify which of the two graphs is representing exothermic and which one is representing endothermic reaction. I'm sure you'll be able to figure out very clearly. Yes. So what has the catalyst done? It has not affected the energy of the reactants. It has not affected the formation of the products. The reactants and the products are the same. The activated complex is also being formed, but the amount of energy required to do that is lower than what is required in the absence of a catalyst. Now, let us say this is you, this is me, right? You want to learn, I want to teach, but we are so far away. How do we interact? Wonderful. YouTube gave us an option to come together and pool in our learning and resources so that we can interact on a common platform. The same way a catalyst. So a catalyst, what it does is, this is one reactant, this is the other reactant. The catalyst says, come on, come. I'll provide the platform and you can be closer and you can be friends and you can be more productive, right? So this is how a catalyst works. Now this is not something that you can write for your exams. You need a technical definition, right? So let's give you a technical definition. A catalyst is a substance which alters the rate of a chemical reaction without itself undergoing any change chemically or in mass. Now, the terms without itself undergoing any change chemically or in mass. So, a catalyst itself is not participating in the reaction. It is simply providing a platform for the reactants to come and react on its surface. Now, this is one way that the catalyst works. what are the different theories behind the working of a catalyst, we shall be doing a little later in the next chapter and also in your advanced studies. Now, we are going to take examples in chemistry. So we have hydrogen peroxide. Hydrogen peroxide has a tendency to dissociate to form water and oxygen gas. Now here I have not listed the states of the substances. This is liquid, this is liquid. Now hydrogen peroxide breaks down. What happens is, if you add a little manganese dioxide to the hydrogen peroxide, or you add lead 4 oxide, the surface is dusty, or the surface is rough, or if there are any metal ions, what do we see is that the dissociation of this hydrogen peroxide into water and oxygen becomes very fast. That is, the reaction gets expedited. In other words, such type of substances are said to behave as a positive catalyst. So, your manganese 4 oxide, lead 4 oxide, dust, rough surfaces, heavy metal ions, light, they all act as catalyst for the breaking down of hydrogen peroxide. So when you go to the laboratory, you will see that hydrogen peroxide is stored in dark colored glass bottles, so that the surfaces are not rough, so that the light cannot enter and cause it to break down. So how do I prevent hydrogen peroxide from breaking down? Because especially it has to be transported over long distances, right? So there should be substances which should behave oppositely as well, correct? We can call them as negative catalyst, or more appropriately, they are called as inhibitors. They stop a reaction, or not exactly stop, they prevent or slow down a reaction from taking place. So what is the inhibitor for hydrogen peroxide? Acetanilide. It slows down the breakdown of hydrogen peroxide, hence the term negative catalyst or an inhibitor. You can observe this in the form of a chart over here. Easy to note down, right? Okay. So in the graph we spoke, do you think we mentioned about a positive catalyst or a negative catalyst? Am I being a positive catalyst for you or a negative catalyst for you? It depends. If you've been able to connect to the learning, then I'm a positive catalyst. But if you are getting disheartened, you are not able to hear my voice, you are not able to understand what I'm writing, then I'm acting as a negative catalyst, because then I am, yes. So the same substance can actually act as a positive catalyst in one reaction and a negative catalyst in the other. So let's look at the differences. A positive catalyst, as we said, brings down a lowering of the activation energy and causes the rate of the reaction to increase. What do you think is the behavior of a negative catalyst? Can you tell me the points for a negative catalyst? How does a negative catalyst work? Yes, a negative catalyst, on the other hand, increases the activation energy, and secondly is it decreases the rate of a reaction. So, are we writing it down? So, can you draw the graph to show the behavior of a positive catalyst and the behavior of a negative catalyst? Go ahead, try and draw the graph for a positive catalyst and for a negative catalyst, the difference in the behavior. So if, let's suppose, if this is my curve, I am not listing down the, so here on the y-axis what do we put? Yes, the potential energy. On the x-axis is the reaction coordinate. Now, if this is the graph for the reaction in the absence of a catalyst, what will be the graph in the presence of a positive catalyst? Yes, the activation energy is lowered. So a positive catalyst, what does it do is it says, okay, boss, come. I'll provide you a platform where you can interact, and both the reactants are happy and able to react to form the products. What do you think will be the graph of a negative catalyst? Absolutely. So if this is my graph for a reaction without the catalyst, how will it be in the presence of a negative catalyst? Yes, it will be higher. The activation energy is higher. Now, these graphs are not complete. Go ahead. Mark what does the y-axis indicate. What does the x-axis indicate? See, I have not marked y, o, x. Whenever you are drawing graphs, what does the y-axis represent? What does the x-axis represent? These are very, very important representations. So supposing if I were to draw this graph in the examination to show the behavior of a positive or a negative catalyst, but I don't mark. I don't tell you, I don't mark that this is the energy of the reactants, this is the energy of the products. I don't mark the activation energy with the catalyst and without the catalyst, right? If I don't mark that, then this graph is meaningless. And tell me, if you were the examiner, would you give me marks for it? No, right? So whenever you are drawing a graph and whenever you are learning a graph, always remember to note what is being represented on the coordinate axis, the y-axis and the x-axis. What are the markings, what are the coordinates that you have marked on the graph? Third, most important thing, draw the graph at least once yourself with your own hand and see whether you've got it right. I am telling you, 90% of us forget one or the other thing. I'm talking about us, means us teachers also, right? Unless we are very seasoned and too much of practice, we also tend to forget at times that we have missed out marking on this. That is why I'm insisting that this graph is very, very easy. Don't miss out on the learning of this graph by missing out on any of these 4 points listed over here. Okay, I had asked you a question. Which one of these graphs represents exothermic reaction and which of these represents an endothermic process? Can you tell me? The top graph would be, yes, it represents an endothermic process because your energy of the products is greater than the energy of the reactants. That means overall, your reaction mixture has ended up with more energy. It has absorbed energy. It has taken up energy. Whereas your second graph, energy of the reactants was greater than the energy of the products. That means now when the reactants change to products, they will lose out the extra energy. I am confident that you all would have got this correct. Let us now do the characteristics of a catalyst. As we said earlier, when a catalyst is being used in a reaction mixture, it itself undergoes no change in mass or its chemical behavior. So when we talk about using manganese 4 oxide as a catalyst, so let's suppose I start with let's say 0.1 mg of manganese 4 oxide to catalyze the reaction or the breaking down of hydrogen peroxide. At the end of the reaction, I will get the same amount of manganese 4 oxide back, although the rate of the reaction would have increased, right? So what it is effectively doing is it is simply altering. Now here if you notice, I have used the word altered. Alter means change. We notice that if it's a positive catalyst, it will increase. But if it's a negative catalyst, it can decrease also. It doesn't affect how much of the products we are going to obtain. No, your learning will be the same. It's only that the learning will be a bit faster. Correct? So there's no effect on the concentration of the products or the reactants. Only thing is it speeds up the reaction. Here we are talking about an equilibrium reaction. So equilibrium means we are talking about a reaction which is proceeding both ways, right? It can go from reactants to products or products to reactants, right? So equilibrium means where both the reactions are taking place at the same rate. But you notice they have to climb the same peak. They have to reach the same cliff, correct? So if I talk about moving from reactant side or I talk from moving from product side, the same effect has to be there. So a catalyst, if it is reducing the activation energy for the forward reaction, it is also reducing the activation energy for the backward reaction to the same extent. So how will it affect the equilibrium? It won't affect the equilibrium. The concentration of the reactants or the products obtained will still be the same. The only thing is we will be able to achieve that equilibrium faster. I hope again that you are noting down these points, because as you see, the name of the channel itself is Pen and Paper, just to encourage you all to keep your pen and notebook separately for this channel so that you have your notes. And it's always a good habit to leave a few lines down so that in case you get some extra material, you can always add it to your notes. There is no end to learning as long as you enjoy it. So we say the next point, characteristic of a catalyst. It works by lowering the activation energy, right? And as we said, it lowers the activation energy of the forward and the backward reaction to the same extent in an equilibrium. A small amount of catalyst can catalyze a large amount of reactants, right? Through one video, teachers can reach a large number of audiences, right? So a small amount of catalyst can catalyze a large amount of the reactants. Why? Because a catalyst itself is not getting used up during the course of a chemical reaction. It has no effect on the Gibbs energy. Remember the topic of thermodynamics? We have dealt with thermodynamics as a separate set of videos. So it affects only by the way, a very, very important point. A catalyst will only affect a spontaneous process. It will not affect the non-spontaneous ones. Why? Yes, because spontaneous ones are the ones which are taking place on their own or by initiation, which have a tendency to take place. Non-spontaneous are those which have to be continuously, come on, go on. Right, we have to continuously supply them with energy in order to do so. So, if you are interested in learning, you will be benefited by this video because you are spontaneous. But if you are being forced to watch this video just to make sure that you learn, that means you are non-spontaneous. No matter how many videos you watch, learning will still remain the same, right? So be spontaneous, be open to learning, not just from exams point of view. Enjoy your learning. Be happy at the fact that you are learning something new every day. Now that we've done the characteristics of a catalyst, what is left in this chapter looks like everything is over. No, we are yet to discuss an important aspect which is known as the collision theory. 50% of it we've already discussed while talking about temperature and while talking about catalyst. We shall formally deal with the collision theory in the next video. So please make sure that you are there, you stay tuned, and you share your learning with friends and classmates. Stay happy, stay healthy, stay safe.